Right now, as you watch this video, there are over 34,000 pieces of space debris, larger than a softball hurtling around Earth at 17,500 miles per hour. That's fast enough to turn a paint fleck into a bullet. But here's what's truly terrifying. That's just what we can track. Scientists estimate there are over 130 million pieces of space junk, smaller than 4 inches, orbiting our planet. Each fragment is a potential catastrophe waiting to happen. One collision creates thousands more pieces. Those pieces cause more collisions. It's called the Kessler syndrome, and we're already living in its early stages. The billionaire space race has accelerated this crisis beyond recognition. SpaceX alone has launched over 5,000 Starlink satellites since 2019. Amazon plans to launch 3,236 more for Project Kuiper. OneWeb, Blue Origin, and countless others are joining the party. They're turning Earth's orbit into their personal playground, but who's cleaning up the mess? The answer is both shocking and terrifying. Almost nobody. While tech moguls race to colonize space, they're simultaneously destroying our ability to leave Earth safely. The very gateway to the stars is becoming a minefield of our own creation. But there's something even more disturbing that space agencies don't want you to know about this crisis. Space debris isn't just an environmental problem. It's a weapon of mass destruction that doesn't discriminate between nations. When China deliberately destroyed one of its own satellites in 2007, it created over 3,000 trackable pieces of debris that will orbit Earth for decades. Russia followed suit in 2021, destroying another satellite and adding thousands more fragments to the deadly carousel above our heads. These weren't accidents. They were demonstrations of power. Anti-satellite weapons, or assets, can cripple entire nations by destroying their communication networks, GPS systems, and weather monitoring capabilities. But here's the twisted irony. Every asset test makes space more dangerous for everyone, including the countries conducting them. The International Space Station has been forced to perform emergency maneuvers 29 times since 2000 to avoid debris collisions. Astronauts have sheltered in escape pods multiple times, preparing for potential evacuation. These aren't rare events anymore. They're becoming routine. Consider this chilling reality. A single catastrophic collision in the wrong orbital zone could trigger a cascade effect that makes space travel impossible for generations. We're not just polluting space, we're potentially trapping ourselves on Earth forever. The very technology meant to connect our world is threatening to cut us off from the universe. But the space agencies tracking this crisis have discovered something even more alarming about how quickly this situation is spiraling out of control. The numbers behind the space debris crisis read like a disaster movie script, except this is reality. Every day, approximately 100 tons of space debris re-enters Earth's atmosphere. Most burns up harmlessly, but pieces weighing several tons regularly survive the journey down. In 2021, debris from a Chinese rocket crashed uncontrolled into the Indian Ocean, missing populated areas by pure luck. But it's what stays in orbit that poses the real threat. The European Space Agency estimates that since 1957, we've launched over 12,000 satellites. Of these, only 4,000 are still operational. The rest? Dead satellites drifting through space, each one a potential collision waiting to happen. The orbital zones around Earth are becoming increasingly congested. Low Earth orbit, where most satellites operate, is experiencing what scientists call orbital overcrowding. The space between 100 and 1,000 miles above Earth's surface contains 90% of all active satellites and debris. It's like trying to navigate a highway where broken-down cars are left scattered across every lane, forever. Here's the most terrifying statistic. Computer models predict that without intervention, the amount of space debris will triple by 2050. We're approaching a tipping point where the debris population becomes self-sustaining through collisions alone. Once we cross that threshold, cleaning space becomes virtually impossible. The question isn't whether a major collision will happen. The question is when and whether we'll be ready for the consequences. Elon Musk's Starlink constellation represents the largest single contribution to space congestion in history. With over 5,000 satellites already deployed and plans for 42,000 total, SpaceX is fundamentally changing the orbital environment. Each Starlink satellite weighs approximately 573 pounds and operates in low Earth orbit for approximately 5 years before burning up. But Starlink is just the beginning. Jeff Bezos' Amazon is developing Project Kuiper, planning to launch 3,236 satellites. OneWeb has already deployed over 600 satellites with plans for thousands more. China's state-owned enterprises are planning mega-constellations that could add 13,000 satellites to orbit. The math is staggering. If all planned satellite constellations are deployed, we'll have over 100,000 active satellites in orbit by 2030. That's 25 times more than we have today. Each satellite represents a potential collision risk, not just during operation, but for years after it stops functioning. These companies argue their satellites are designed to deorbit safely at the end of their operational lives. But failure rates are inevitable. Even a 1% failure rate across 100,000 satellites means 1,000 dead satellites permanently stuck in orbit. And that's assuming everything goes according to plan, which history suggests it won't. The regulatory framework governing these deployments is woefully inadequate, created for an era when space launches were rare government affairs, not commercial ventures launching dozens of satellites weekly. If you're feeling overwhelmed by the scale of this crisis, you're not alone. But here's where the story takes a hopeful turn. Around the world, brilliant minds are developing revolutionary technologies to clean up space. And if you want to stay updated on these incredible innovations and other crucial stories about our planet's future, consider subscribing to our channel. The European Space Agency is leading the charge with ClearSpace 1, scheduled to launch in 2025. This groundbreaking mission will use a spacecraft equipped with robotic arms to capture and deorbit a piece of space debris. It's like a garbage truck for space, designed to grab defunct satellites and guide them into Earth's atmosphere where they'll burn up safely. Japan's Astroscale has already demonstrated orbital debris removal technology with their ELSA-D mission. Their spacecraft successfully captured and released a test satellite multiple times, proving that space cleanup is not just theoretical but achievable. They are developing magnetic capture systems, harpoons, and nets specifically designed to snare tumbling debris. Switzerland's ClearSpace is developing even more ambitious plans. Their technology uses artificial intelligence to identify and approach debris autonomously, then capture it using flexible robotic arms. The captured debris is then guided into a controlled re-entry trajectory, ensuring it burns up completely over unpopulated ocean areas. But perhaps the most innovative approach comes from Remove Debris, a mission that tested multiple capture technologies including nets, harpoons, and drag sails. Their experiments proved that space debris removal isn't just possible, it's becoming economically viable. Despite these promising developments, the cleanup efforts face enormous challenges. The cost of removing a single piece of large debris ranges from $50 million to $200 million. With thousands of dangerous objects in orbit, the total cleanup bill could reach hundreds of billions of dollars. Who pays for cleaning up space when the companies creating the mess are private corporations? The technical challenges are equally daunting. Space debris moves at incredible speeds in unpredictable orbits. Approaching a tumbling satellite requires precision that makes landing on the moon look simple. One miscalculation could create even more debris, making the problem worse instead of better. International cooperation remains the biggest obstacle. Space debris doesn't respect national boundaries, but space law is fragmented across dozens of countries with competing interests. Russia, China, and the United States all operate major space programs but have different priorities and limited trust in sharing orbital data. time is running out faster than most people realize. Computer simulations suggest we have less than a decade to implement large-scale debris removal before the problem becomes unmanageable. The Kessler syndrome isn't a distant threat. It's a present danger accelerating with every new satellite launch. The window for action is closing rapidly. Every month of delay makes the cleanup more expensive, more dangerous, and more technically challenging. We're literally racing against physics itself. The space debris crisis represents more than just a technical challenge. It's a test of humanity's ability to govern the commons responsibly. Space belongs to all of us, but we're allowing it to be polluted by the few who can afford to reach it. The solutions exist. Active debris removal missions are proving successful. International frameworks for space governance are being developed. New satellite designs include built-in deorbit capabilities, but implementation requires unprecedented global cooperation and massive financial investment. The stakes couldn't be higher. Failure to address space debris could end humanity's space age before it truly begins. Success could open the door to sustainable space exploration for generations. We're at a crossroads where the decisions made in the next few years will determine whether space remains accessible to future generations. The billionaires racing to space have the resources to be part of the solution. Some, like SpaceX, are beginning to incorporate debris mitigation into their designs. Others remain focused purely on deployment. Public pressure and regulatory frameworks will determine which approach prevails. The orbit crisis is solvable, but only if we act now. The technology exists. The knowledge is available. What's missing is the collective will to treat space as the shared heritage of humanity rather than a private playground for the wealthy. The choice is ours, but time is running out. We can either clean up space together or watch our gateway to the stars become permanently closed by our own negligence. Thank you for joining us on this critical examination of the space debris crisis. This issue affects every person on Earth, yet receives far too little attention. If you found this investigation valuable and want to stay informed about the crucial environmental and technological challenges facing our planet, please subscribe to our channel and hit the like button. Your support helps us continue bringing you the stories that matter most for our collective future. Together, we can ensure that space remains open for exploration, not closed by pollution.